Let's look at question number 5. It's exercise 10G on page 448. Consider the curve, this function here, where x is not equal to -1. A, find the equation of the normal to the curve at the point 2, 2. Okay, we're going to use the quotient rule. So I've put that over here. And let's go ahead with that. Let u equal, that's 4x minus 2. Therefore, du dx equals 4. And v equals x plus 1. Therefore, dv dx equals 1. Now we'll get the derivative of this function. Dy dx equals, I'm using the quotient rule, so it's v. So we're going to model that, v by that derivative, and then this u times that derivative, and then we're going to divide by v squared, that one squared. Let's write that up. So on the top we have v, and v is defined as x plus 1. Let's write that in, x plus 1. And that's multiplied by du dx, that's 4. And then we minus u, which is 4x minus 2 times dv dx, which is 1. And we divide by v squared. Now we define v as x plus 1 squared. Okay, so let me just go across to here. Okay, so we've got 4x plus 4 minus 4x plus 2. And on the bottom we've got x plus 1 squared. I'll go back over to here. So that equals, on the top we've got 6. And on the denominator we've got x plus 1 squared. Now we have the derivative of this function here. Now the derivative gives us the slope at any point x. We've been asked to look at the point 2, 2. So what we need to find out is the slope of the tangent at x equals 2. So let's substitute that in. At x equals 2, dy dx equals 6 on 9, which is 2 on 3. Now 2 on 3, we know that dy dx equals the slope of the tangent. Okay, and that's 2 on 3. Therefore, the gradient or the slope of the normal would be the inverse and the opposite sign. So that's going to be minus 3 on 2. And that is equal to the normal gradient. Now what we need to do is to find the equation. So to find the equation, we've used this before. We use y minus y1 equals m times x minus x1. Our m is minus 3 on 2. Our y1 is 2, and our x1 is 2. So let's put those in. We've got y minus 2 equals minus 3 on 2x minus 2. That's y equals minus 3 on 2x plus 3 and then plus 2, which is minus 3 on 2x plus 5. Okay, let's have a look at B. Find the coordinates of the second point at which the normal intersects the curve. Well, if we want to find out where the function value is the same for the line and the curve for a certain value of x, then what we need to say is we say that this equation here, that line, where that line equals that function. So we're going to do that. So we're going to put this down as 4x minus 2 divided by x plus 1 equals minus 3 on 2x plus 5. I'm going to resolve this. So that would be 4x minus 2 equals x plus 1 times minus 3 on 2x plus 5. That would be minus 3 on 2x squared plus 5x minus 3 on 2x plus 5. Okay. Let's move everything to the right-hand side. 0 equals minus 3 on 2x squared plus 5x minus 4x minus 3 on 2x plus 5 plus 2. Now that equals minus 3 on 2x squared. Now these three terms here, got plus 5x minus 4x, well that's x, minus 3 on 2x would be, that's minus 3 on 2x, there'd be minus a half x here. Minus a half x plus 7. Now we have to solve that. Let's multiply everything by 2. So with 0 equals minus 3x squared minus x plus 14. We just need to solve that. So let's go to our calculator. Okay, so we're using the graphic display calculator, the Inspire for this, and we come up with two solutions. Now, obviously one of the solutions is going to be that point 2, because we know that is an intersection point because that's where the tangent touches the curve. But we had to find the other one. Now we're finding the other one. So using the calculator, the GDC gives us x equals minus 7 on 3 and 2. Now that's what we were expecting. One of those we were expecting. That's that one. Okay. So now we know it's this one. But the question was find the coordinates, not just the x value. So we have to put the minus 7 on 3 into here to find the y value. So let's do that. So we're going to have y equals 4 times minus 7 on 3 minus 2 divided by minus 7 on 3 plus 1. That's going to be minus 28 on 3 minus 2 divided by, so we've got minus 7 on 3 plus 1. Well, 1 is 3 on 3, so that's going to be minus 4 on 3. That's going to be minus 28 on 3 minus 6 on 3. And that's all multiplied by 3 or minus 3 on 4. And that equals, okay, lucky for us, with both, these are divided by 3 and also it's multiplied by 3. So inside the bracket is now going to be 28 plus 6. And it's divided by 4. So 28 plus 6 is 34. 34 on 4. And that equals 17 on 2. So the coordinates are x is minus 7 on 3 and y is 17 on 2. And we'll write that down here. So that would be minus 7 on 3 and 17 on 2. And that would be the solution for B.